Slide 1. Welcome back. Let's recap what we have done so far using our market for wood-turned pens as an example. It is best to watch this video after you have watched the videos Market Demand Revisited, Market Supply Revisited, and Market Equilibrium. Slide 2. So far, we have taken the supply and demand model introduced by Alfred Marshall and shown how to construct supply and demand curves from the individual reservation values and unit costs of buyers and sellers. Slide 3. Next, we looked at the competitive equilibrium theory as a theory of price formation and exchange allocations in our market. Slide 4. Today, we are going to look at market efficiency. We can think of market efficiency as a benchmark for market performance. When we look at the performance of actual markets, we can ask how efficient they are relative to our benchmark. Slide 5. Competitive equilibrium theory predicts that at equilibrium, the resulting market allocation will produce maximum efficiency. So first, we have to define what we mean by efficiency. Slide 6. In our market for pens, we consider the following exchange. Tim buys a pen from John for $6.25. This exchange consists of two transactions. Tim gives John $6.25, and John gives Tim a pen. This is what we could observe, but there is additional unobserved data. Tim just bought his first pen, which has a reservation value of $8, and John just sold his first pen at a unit cost of $3. Given this data, the gains from exchange can be calculated as $8 minus $3, which equals $5. Slide 7. Given the price of $6.25, we can divide the benefits from the exchange between Tim and John. Tim's benefit, also called buyer surplus, is calculated as $8 minus $6.25, which equals $1.75. John's benefit, also called seller surplus, is calculated as $6.25 minus $3, which equals $3.25. On the supply and demand graph, we show these benefits using purple rectangles. Notice, if we add Tim and John's benefits, we get back their gains from the exchange. Slide 8. Suppose all pens trade at a price of $5. Then, at this price, Brian will buy 2 pens. Tim and Kevin will each buy 1 pen. Also, Gavin will sell 2 pens. John and Dave will each sell 1 pen. From this information, we don't know who sold to whom, but we do know that the total benefits or gains is the purple area shown on the graph. If we add up these benefits, we see it is $20. Slide 9. For our pen market, the total surplus calculated assuming everyone trades at the equilibrium price of $5 is the maximum surplus that can be generated. Can you explain why? Here is a hint. If we have fewer trades, then some of the benefits would be lost. Slide 10. The maximum surplus calculated assuming everyone trades at the competitive equilibrium price can be used as a benchmark to measure the efficiency of actual markets. In an actual market, people will make trades at different prices. Let's see how we can calculate actual efficiency from these trades. Slide 11. Suppose in our market for pens, the market period closes, and we see the following outcomes have occurred. Brian and Tim have each bought 1 pen, and Kevin has bought 2 pens. Furthermore, Gavin and Dave have each sold a pen, and John has sold 2 pens. Can you provide a set of prices and trades that would have generated this outcome? There are many. Take a few minutes to think about an answer. Slide 12. Okay. Here is one answer involving 4 trades. In the first trade, Kevin buys a pen from Gavin for $4. We can graph the surplus generated with teal rectangles. For Kevin, it is his first reservation value minus price, or $7 minus $4, which equals $3. For Gavin, it is price minus his first unit cost, or $4 minus $1, which equals $3. Slide 13. In the second trade, Kevin buys a pen from Dave for $3. I have added red rectangles marking the surplus for Dave, which is $3 minus $2, and the surplus for Kevin, which is $4 minus $3. Slide 14. In the third trade, Brian buys a pen from John for $6. I have added purple rectangles marking the surplus for Brian, which is $9 minus $6, and the surplus for John, which is $6 minus $3. I made the second rectangle slightly thinner so you can still see the teal rectangle underneath. Slide 15. In the fourth and final trade, Tim buys a pen from John for $7. I have added green rectangles marking the surplus for Tim, which is $8 minus $7, and the surplus for John, which is $7 minus $6. Slide 16. Okay. We have all the trades. Now we calculate the gains from trade or surplus for each trade. Slide 17. Now that we have our 4 trades, we can add up the gains from exchange as follows. The first trade between Kevin and Gavin produces $7 minus $1, which equals $6 in surplus. Note that $7 is the reservation value for Kevin's first unit and $1 is the unit cost of Gavin's first unit. For the second trade between Kevin and Dave, we use Kevin's second reservation value and Dave's first unit cost. $4 minus $2, which equals $2 in surplus. The third trade between Brian and John produces $9 minus $3, which equals $6 in surplus. And the fourth trade between Tim and John produces $8 minus $6, which equals $2 in surplus. Adding up all the surpluses, we get $16 in actual surplus. Side 18. There is an alternative way to calculate actual surplus. We can sum up the reservation values from the units bought and subtract the total cost of the units sold. The sum of the reservation values is $9, plus $8, plus $7, plus $4, which equals $28. Total cost is $1, plus $2, plus $3, plus $6, which equals $12. Thus actual surplus is $28 minus $12, which also equals $16. Slide 19. We can divide actual surplus by the maximum surplus, and we see the market, based on the trades we examined, is 80% efficient. Notice this is calculated as $16 divided by $20, which equals 0.8. We can make 0.8 a percentage by multiplying it by 100, giving us 80%. Slide 20. Thank you for watching this video. If you have any questions or comments, you can leave them in the comments section below.